These two functions, and you don't really need to know this, are what we call power functions because they have exponents that are rational exponents on the variables. Remember, we defined polynomials in chapter 2 where they had to be positive whole number exponents. Now, if we have rational exponents, these are power functions. So we're going to be working with some power functions here. So we're going to be talking about operations with these power functions. So I've just defined two of them for you, f of x and g of x. The majority of this work, this is the way we'll go about doing it, is we'll define the functions first, and then I'll ask you to do various things with those functions. For example, if I asked you what is f of x plus g of x, it would be those two, so it would be 4x to the 1/2 plus negative 9x to the 1/2. Can I combine those? Why? They're the same exponent, same base, so they're like terms. So what is 4x to the 1/2 plus negative 9x to the 1/2? Because when we add terms, we combine the coefficients and we leave the exponents alone. Okay? What if I asked you to subtract them? Same thing. And I'm not going to spend a real long time on the addition and subtraction because I'm going to assume that you can add and subtract. Because you added and subtracted polynomials now. It's just that the exponents are a little different, but it's the same concept. I get 13x to the 1/2. Okay, everybody okay? Okay. Redefine. I'm going to give you a new f and a new g. And now I'm going to talk about multiplying them for just a minute. Let's see. Actually, I'm going to give you I'm just defining functions right now. I've not asked you to do anything with them yet. I'm just giving you.
You word yet.
Evan, are you complaining?
No. Stop throwing something. Oh, you shouldn't have.
Okay, let's do multiplication. And I think you'll see the reason why I set you up some different functions here. When you multiply and you have a couple of terms here, what do you have to do?
FOIL.
Distribute, FOIL. So remember, when I multiply, I have to multiply coefficients and do what to exponents? Add them. So this becomes 8x 1/3 plus 1/2. Somebody with a calculator.
You have to be the same denominator.
1/2 plus 1/3. They got to have a common denominator. 5/6. Thank you, Jonathan. Probably what? Well, I would do this on the calculator if it was me, but if I didn't have one, I'd find a common denominator of 6. So I'd get 3/6 plus 2/6, which is 5/6.
Wait, when I put that in my calculator,
Oh,
that's not how that works.
Yeah, I got a decimal.
Yeah,
Hit math, enter.
like, what do you invent?
So your fractions have to be in parentheses. So you're going to be parentheses 1 divided by 2, close parentheses. Oh, yours. Oh. There's. Oh, no. It seems like there's a little bit of confusion on both parts. The first bit of confusion was, why do we leave it like this? Why are we stopping? Well, we're stopping because they're not like terms. We can't combine them. The second bit of confusion was, wait, we didn't do anything with the h. Well, you only use what you referenced. So I said do f of x plus g of x. I mean times g of x. Now I'm going to ask you, using those same functions, what is h of x divided by g of x? Now I'm going to reference h of x. So set them up in your fractions. H is 20x to the 1/4. G is 4x to the 1/3. And simplify.
How?
How?
How? Well, you divide.
Simplify coefficients. 20 divided by 4 is?
Is 5.
What do you do when you're dividing with the same base? What's 1/4 minus 1/3? Somebody with a calculator, if you would please. Negative 1/12. This is a great one because now I get a negative exponent, and what happens with negative exponents? Okay, I don't know what that means, but the 5 stays up top and the x with the negative exponent goes in the bottom.
Wait. Why did you drop the 5?
The 5 is its own piece. It has its own exponent of 1. It's imaginary, but it's there. So it stays up top while the x is the one that moves.
Yeah, I thought it's maybe.
Okay.
Why? Yeah, it's the section going to be like the same thing we've been doing, except you're just.
We're doing operations. No, the new part's probably going to be the composition I'm fixing to show you.
Well, I'm worried because this makes sense.
This is the easy part. This is the easy part. Some very easy functions. Make sure you're drawing lines or something in your notes so you know we're changing f and g every time we do this. I'm going to redefine f, and I'm going to make these just some simple polynomials.
Will there be harder polynomials later?
Yes. All right. Slightly easier polynomials here. Now let me ask you this. If I asked you to find f of 5, tell me what that means.
Just put 5 in the function?
You just put 5. Whatever sits, this is the key to composition, okay? Whatever is in this parentheses replaces every x. It does not matter if that is a number, a variable, a word, a function, a picture, it doesn't matter. Whatever is there replaces every x in that function. So I call up f of x, ring, ring, ring. No, I'm just kidding.
I just got that.
Okay. Cold medicines are getting in my head, I think. All right, 2. It's not x now. It's 5. And I would get in the habit of always parenthesizing, if that's a word, what you're plugging into the function, because sometimes there are exponents hooked there that need to apply and other things. So you want to make sure you put it in parentheses. So everything stays the same except the x, and it comes out and a 5 is replaced. Now I can simplify. 10 plus 3. Okay. I'm starting easy. That's your toe in the water right now. We're going to be completely submersed in just a minute. That's your toe. That is your toe now. Let's get our foot in now.
Wait, so define x, you did 2 plus 3.
Oh, yeah, 13. Sorry. All right, now your whole toe, not just your toenails in there. I forgot to simplify. Okay.
Our whole toes?
Yeah.
Fixing to put the foot.
I don't want to put it out at the glove and next. Here we go. See, there we go.
The foot is being submersed in the water.
Oh.
People like Olivia who don't like feet in the water, she's putting her hands in first.
Oh, so all.
So you're going to get 3.
All the x's get an x plus 3. So it's 2. It's not x anymore, but it's
X plus?
Plus.
Now I can simplify.
What? Never mind. Every time I look up, there's a whole other line. Now you got
E.
Yay.
Isis, what you got?
Why do we use x plus 3? Is that just
I'm just telling you what to do.
Oh,
Yeah,
okay.
I'm giving you something and you're doing it.
Okay, sorry.
Against our will.
Going in up to the knee.
Oh.
No. You see, you shouldn't even tell him. You should just wait and see how long it takes him to see.
I was asking her what's on that.
What does this become?
Colin squared.
Colin.
I'm not writing that, so please give me a number.
I'll go with this, I like it.
Okay. The point that I am driving home to you is it does not matter what is in parentheses. That is what is replacing the x in that function. Okay?
Let's do Olivia next.
Whoa, see, so now you're doing this.
Waist deep, waist deep.
No.
Oh, wait,
This is the way I read this. This is f of x. This is f of 5. F of x plus 3. This is f of g of x.
So you plug in x squared.
So you just plug in x
So
squared.
I am going to replace. I'm going to replace g of x with x squared because that's what g of x is.
Why'd you write f again?
F's on the outside. Only thing I did was I replaced g of x with x squared.
Can you just write two for x squared plus?
Yes, but whenever it gets bigger, you'll want to get in this habit of putting what you're replacing x with in parentheses. All right, look. What is g of x? What does g of x equal? G of x is x squared, right?
Yes.
Guys, so I'm just substituting. This is constant substitution. Now, everywhere there's an x in f, I'm going to replace it with x squared. So I look at f and I say, oh, it's 2 times x squared plus 3. We're up to our waist.
We're up to our waist. Okay, we're gonna drown, seriously? No, not seriously, but like,
Can we swim first?
I can swim.
Most of us.
I mean, I can see.
Oh, so we're just replacing all the x with the function?
Yeah, it's just
With the whole function. So now, what is f of x?
2x plus 3.
Hey, can you just like give it a second? Tell me the answer.
There's some people still in trouble.
I take f, which is 2x plus 3. I take out the x, and in its place I put. I'm plugging it into itself.
4x plus 3.
Let's dunk.
Wait.
Slam dunk.
We're gonna back.
You tilt your head back in.
I never realized I did that, but somebody in here, it might have even been Sailor, said that I do that, and I throw my head back. That's whenever I really think it's funny, I guess. I don't know. I'm not gonna redefine my F, my G, and my H. But I want to leave enough up here for y'all to still be copying if you are. All right, guys, stay with me. Oh my gosh, come on, pen. All right, y'all ready to dunk under the water?
baptized.
Oh, so we all drown.
We need Lord's help.
Well, I'm not drowning, but it's already
Let's do
Sarah, the beta club induction.
More sounds better. You can put the H's. Whoa.
Okay, so.
All right.
I know what you're doing.
your key to these guys. Your key to these is going to be to work inside out. So the first thing, I need to know what this is so that I can move forward, Cullen.
Okay.
So my question is, what is h of 4?
6, 2, plus.
Every x is getting replaced with 4. I'm doing what I started with. I'm just taking this a step at a time. And if you do it a step at a time the way with what we started by just evaluating at a single value. What is 4 to the 1/2? 2. I hope no one had to use your calculator for that. Because exponent of 1, some of y'all are looking at me like I'm crazy. The exponent of 1/2 is the same thing as a, somebody say it. Square root. Yes. All right, so all this is doing is this is telling me h of 4 equals 18. So that says now I can do, I can do g of 18 to evaluate this. So I get 18 squared. Which is, what is it? 324. And now we are swimming gracefully through.
No, you just dropped a new board.
Please.